Cool.
Yeah. So welcome everyone. This is the talk about SBT 1.0. I'm Josh Suereth.
I'm Eugene Yokota.
And we love feedback. All right. This is, we're both from Typesafe. Yeah, name of the talk. The two of us are part of the reactive platform team. We'll just tell you what we do at Typesafe. We're the team that builds infrastructure. If those of you familiar with SBT, we work on SBT. Those of you familiar with dbuild, we work on dbuild. We work with Activator, and we actually build the certified build of Typesafe. So that's who we are, what we do. So we do a lot of building. Today we thought we would give you a brief and mostly incomplete wrong history of build tools, and then talk about the roadmap for SBT 1.0 and a little bit about SBT Server.
All right, so let's start with the brief history of the build tools. This is one of the first known build tool in the history. This is supposedly the build script for making the system file for PDP-11.
Actually, if you go back to that, I'm pretty sure that hand was the important part right there. Anyway, okay. So next up is make and make files. For those of you who are used to build files, make introduced us to the notion of very, very clear and concise syntax that no one will ever confuse. It should be obvious where, for example, this CC thing is coming from and $@. This actually was very influential in the design of SBT and its syntax. What's the donut about?
So it's the one ring that unites us all. So effectively, okay. So what we like to think about the history in the build tool of what question does each tool answer, and the question that make answered is how do I build this program, right? In the shell script days, each program had their own build, but now with make you have this unified tool that you can do a dependency-based programming. So that's pretty cool. The downside is that it's using the system level command to carry out the actual tasks. So what would be the problem then?
The problem is that then you couldn't actually cross machines with make unless the actual executable or command that it was calling was something that was on multiple machines. If we go back and just take a look on the dependencies, I just want to clarify in the syntax, hello is a target, and the things on the right-hand side of that colon are the dependencies. Dependencies are explicit files, and it just builds a big build graph, and you type in a thing to build, and it looks at the dependencies and runs all the commands. So yeah, all right. Next up was autoconf and automake. How many of you guys used autoconf and automake? Anyone? Yeah. All right. How many of you wrote M4 macros? Okay. Cool. Cool. Brethren. All right. What we did with autoconf and automake was we decided that makefile was a little too verbose to write and kind of confusing. So you try to make these high-level templates that will generate a makefile for you. The high-level templates were like, I have a library, I have a binary, and I want you to create a build file for me that builds a library or binary, or mix the things together. You had this other thing of cross-platform where there was a configure script. The configure script will look at your machine, figure out what's available, and then alter your build for what's available, okay?
So what question was actually asking, right?
The question was, I have a particular machine that's similar to all the other machines I'd like to build on. How do I build on this particular one?
And that's happening right around 1991, 1996. And then the internet happens, right? This is the, if you can kind of go back to the days when the internet happens, this has this massive effect of connecting all these computers and the open source happens. So it may not be completely obvious from today's perspective, but when it happened, there was this massive change in the paradigm. And of course, the one who gets the most amount of credit is hypertext markup language. That's why internet was so successful. And there, to make the generalized version of the HTML, we have the extensible markup language, which we can now replace all these shell script using XML, which is what the Ant is.
This is under the assumption that people like angle brackets better because of HTML, right? So what Ant does is it brings the same kind of task dependency mechanism with a almost Turing complete XML syntax. So
this is another way of looking at Ant, is that it kind of homogenized the how do I build on this particular machine by shipping all these, what was previously the shell script, like the command that was installed on the particular machines, to common libraries. So if you remember Ant days, there is one page that you always go into. It's called like a task page, where it has like a make dir, Java-C, and jar, and all the stuff you use to type it into the shell. Now you can write it using the the angle brackets, basically.
Yeah, so the beautiful thing is here is basically what Ant gives you is when you type Java-C, it didn't actually call the executable Java-C, which was not cross-platform. It had a little shell that would try to fix it for every single platform and give you something that you can reuse. That was the beautiful thing. The problem was, when you tried to reuse an Ant build file, what you would do is you'd go to your previous company and you would steal the build file, and then you would copy it to your next company, and then all of the things that you did right, you brought, and all the things you did wrong, you brought along.
So roughly around the same time, I don't exactly know which one was the first. I think the earlier ones that I found was the CTAN, which is, I think, the template for the tech or TEF thing that happened in 1993. But roughly coinciding with the internet, which connected everyone's machine, there was this concept called package managers, so that you can now download the metadata to track the library dependencies. And so you have this one library and like a version number, and then it depends on some other library. So the port happened in 1994, RPM happened in 1997. So simultaneously, there is this whole notion of the package manager. And this answers the question of, how do I find my library source code or the binary?
So along comes 2004. We're still in the heyday of XML. And a build tool called Maven comes along. And Maven was designed to solve a few problems. One was consistency across builds. I would like every build in my company to have the same feel. I want to be able to come in and type compile and have it do the same thing. The other problem it was solving in the Java ecosystem was that Java, being a virtual machine and not a platform, didn't actually have packages yet. So if you wanted to use a Java library, you would download a jar and shove it into a directory, and then hopefully remember what the version number was. So if a bug is reported or security vulnerability happens, you know to upgrade. Usually you don't. You just have a jar there and you try to throw another one in, and maybe it works, I don't know. So Maven tried to automatically look at your dependencies, find jars, and create a whole ecosystem around that. What was new here was this idea of convention over configuration, where you have this default build configuration that you don't have to specify. The only thing you have to do in XML is specify differences from the default build. The other thing was it had a notion of plugins where there were hard-coded life cycles where you can plug in additional functionality into the build. So there's this hard-coded convention lifecycle that everybody has, and you can put in custom tasks, right? So the problem here is, though, that was really difficult to customize. If you wanted to make a Maven plugin that did something differently than the default, you were kind of out of luck. For example, the Maven Scala plugin, which I've worked on, when we wanted to cross-compile with Java and do incremental compilation, we actually will run the Java compiler, and then Maven will try to run the Java compiler because we can't tell it not to. So you have a very limited amount of customization you can do.
So another thing to know is this year 2004, because this is sort of the inflection point in the history of all the build tools. Ivy came out in 2004. This answers the same question: how do I find library source and binary? And this, as you see, this is 2004. So as Maven 1 and 2 are maturing, Ivy was kind of coming on right alongside to basically grab the same kind of idea of tracking the metadata and library dependencies. And this adds the Maven's functionality on top of Ant. That was sort of prevalent. Then, this is a little back, this is 2003. But there's another kind of revolutionary idea within this build tool. You can think of it almost like make, right? But it's using the actual programming language to describe the dependency-based programming, and that's rake from Ruby.
With the syntax that does remind me a lot of make. Hopefully everybody here likes make syntax. All right.
So the two questions that it asks is similar to make, right? It says, how do I build on this machine? And how do I customize my build? So previously it was difficult to kind of customize. Now we have the full power of the scripting programming language, and it answers the question of how do I build on this particular machine, because these scripting programming language ships with the standard libraries to do like file operations and things like that.
Yeah, one of the beautiful things about Rake is that it was so comfortable for people used to make. And what were Ruby developers using at the time? Make. So the syntax really blended well and just was so comfortable. And it solved a lot of issues. So yeah, this really changed the shape of the ecosystem as much as Maven.
And then right around the time, I think there's this whole generation in which the XML is no longer fashionable. So there is the REST JSON attempt to replace the SOAP, and this happens, I don't know, right around this time as well.
Yeah, I think Sax was invented, you know, around what, 2005, and it was declared uncool in 2006. So, yeah, it was a pretty quick transition there. But basically people started getting fed up with XML and trying to look for things that were less verbose, but equally expressive.
So combined with all these movements, now we have a combination in which we have, how do I customize my build? You use internal DSL using a real programming language. And how do I find the library source? So the two forces of the Rake and the Maven now combines in various ecosystems. And Builder happens in 2008, Gradle happens in 2009, Lenigan happens in 2009. So there is each programming, like the community basically copies this idea of using the programming language to describe the build. And you can essentially see SBT sort of also as an offshoot of that philosophy.
Yeah, so SBT was started to answer a few questions, right? At the time, you had to solve where do I find sources and binaries. You had to have a solution for that. You had to have customizing builds, and we ended up using Scala. And the other thing SBT was trying to solve was how do I make Scala development as fast as possible. It was actually invented by a PhD research student who was trying to use Scala to write his simulations and was frustrated with compilation speed. So he decided to write a build tool to solve this problem, and then ended up becoming a build tool author instead of a PhD student. So the things that he added and are core in SBT, I'm going to start backwards a little bit, but the notion that everything is parallel by default. So by default, if you have tasks and a task graph, we try to execute as many paths as possible by default, which was very different from a lot of existing build tools, and one of the things that caused a little bit of struggle in the early SBT days, which I think is a lot better now. There was an interactive shell, so you could actually interpret Scala code directly. That was one of the big driving features of SBT, very rapid development. I can download a bunch of libraries and just type in there. There was incremental compiler. That was the big feature that I think made SBT get adopted. The fact that you can reduce the amount of time it takes to compile your project if there's small changes. Finally, it had ANSI colors, and the world was dying to have ANSI terminals come back. Like, so many people love the console. That actually was a driving feature of SBT.
Yeah, so in a way, it was almost like an integrated development environment in this 1990s text terminal, essentially, right?
Yeah, around 2009, if you were doing Scala development, SBT was your IDE.
So I wrote the test framework abstraction as a new here, but it's actually, there's one in Maven already, right?
There is one in Maven, yeah. They came out around the same time.
Right, but so it's cool that you can now test, and then the major testing frameworks like Specs and Scala Test we know their semantics to be able to run like a test only and things like that.
Yeah, I think the new thing in SBT was that the test frameworks themselves actually implemented the test interfaces. Whereas in Maven, it was like a bootstrap after the fact thing. So also around 2009, Google, Blaze, and Bazel first hit the public awareness. And this is an interesting idea here. This is so it takes a lot of ideas from Automake, but instead you try to make every single high-level task incremental. You try to cache everything that you do. Make everything idempotent, cache the heck out of it, do it remotely in a cluster so that if you have a company that, say, has maybe 10,000 engineers and one person runs a build, if somebody makes a change to a file, they only rebuild the smallest amount.
So what question is it actually answering then?
It was actually answering the, if I'm in Pittsburgh and it takes me 4 hours to build the Google web server, can I do it in 20? Which is what happened, 20 minutes instead of 4 hours. And that actually happened with Blaze. So.
Well, also it answers a question of the how do I avoid the version conflicts? And we saw a little bit of that in the Twitter talk, right?
Yeah, so Google Blaze is built against a monorepo, which means all of the source code is known, all of the dependencies are known, and you always assume you build everything from scratch or you have a single binary for something. There is no version management, dependency conflict resolution, that sort of thing, because everything that you look at needs to be 100% compatible. It is a total universe assumption. So next up comes Pants and Buck. Pants and Buck are essentially engineers at Google that had used Blaze that were like, this is a great idea, why did no one else do this, and are working on it remotely. There's also Nix came in sometime around here, which is meant to solve a similar problem. But it's the same idea, just they happen to be open source first.
So this is kind of the history and the tree sort of thing, where we see the make that happened in 1977, and as you see the Maven and the Rake that branches out into all these various build tools.
So these are basically the ideas of build tools, what you've probably seen, popular ideas, and you can see where SBT fits. We're definitely influenced heavily by Rake and Maven, and we've recently been getting influenced a lot by Blaze, Pants, and Buck.
So what's that box?
This is actually, I don't know if you know this, but shell scripts are still around as build tools. John Priddy himself actually generally uses shell scripts to run builds. So we thought we'd just mention that they're not dead. He has a stone tablet, he chisels them in.
And there's also the yet another build tool too, right?
Oh, yet another build tool.
That's not released yet.
We didn't know about yet another build tool release date, so we didn't put it in here. So hopefully 2015. All right. Also, if we go back, I would actually say yet another build tool is in the same vein as like a Google Blaze, which comes more off of a automake, autoconf thing. So, okay. So just a recap, things in SBT. We have dependency-based programming. It's all about a dependency graph. It's all about this internal build DSL in Scala, where I can write actions in Scala and I can manipulate my graph in Scala. We have package and library management, convention over configuration. There is a default SBT build. Hopefully, if you're not doing anything like crazy, you can generally use that and just configure little tidbits. And we have reusable build flows, right?
But these are the things that we inherited from the history of the build tools, basically.
Yeah. And what we add is this notion of interactivity and parallelism. The parallelism, I think, is where a lot of the innovation ended up happening in both plugins, how to design them, and in terms of how to craft a DSL that prevents people from screwing up parallelism. That's actually probably the hardest part. Early SBT versions, there were a lot of parallel bugs. Even now, sometimes you see a parallel bug here and there. Generally, the DSL will prevent you from doing something bad. Some people would say it does it through frustration, but I don't know. I think it's the easiest way to write parallel code.
All right, so moving on to the second part, I want to basically talk about the roadmap to the SBT 1.0 and kind of show where it's going. And it kind of separates into the two parts, which is I'll talk about the stability and the recent development around 0.13x series. And then Josh is going to talk about the SBT server. And generally, it goes into this whole theme of modularization. So the SBT 1.0 technical previews. So typically, when you add new features, you will basically, bump up your version number to 0.14 or something like that, and then you keep adding features 0.15. But we have this thing called the plugin ecosystem in which we don't really want to disrupt so frequently. So what we decided to do is that we would add features into the 0.13 series without breaking the binary compatibility. So when we actually bump up to the 1.0, we're not really experimenting too much. So 0.13.5 onwards, we consider it to be more like a technical previews that it's getting ready basically to be 1.0.
So how many of you guys use plugins in your build? How many of you guys like it when the plugins break? Okay. That was the assumption we made.
Right.
All right.
So another thing that we have been trying to do is kind of like, offload some of the responsibility gradually to not just the two of us, but also to get more help from the community. And this is not only just coding, but around documentations or helping other people in the community and answering questions. So I just want to highlight a few that just came to my mind while I was just like looking through. We have a new committer from the community, Dale Wynand, I'm guessing is I'm sorry if I'm not pronouncing correctly. But he has like 22 pull requests. He's been adding like really interesting features and fixing bugs. So one thing that this happens, I think, in 0.13.9 is that, or 8, is it 9 or 8? I'm not sure.
It's
but
9. Yeah.
we no longer require the colon underscore star when you add a sequence into the settings. And another that's coming up is a minus equals and minus minus equals. So you can do something like if you have like a compiler options or something like that by default, and you want to minus equal it and get rid of something. Big stuff that happened during the technical preview series is the Warsaw Scala community got rid of the blank spaces between the build.sbt, and it's basically a community of people hacked around this feature.
How many of you guys liked having blank lines between all the settings in SBT? Anyone? I think I saw a hand.
There's one hand
awesome.
right there.
Okay, we'll talk later. All right.
There's Martin Duhan who will be joining us during the summer as intern. He's, I think, a master's student at EPFL. He's been working around the incremental compilation of the macros. And there is also Andrew Johnson who's been contributing some interesting features. Cool. So do you want to talk about the auto plugins?
Sure. So one of the things in SBT that I think it was important, our plugin ecosystem, we kind of had an API for plugins that was a little, like it did what it needed to do, but it wasn't quite good enough. And one of the problems was actually around plugin dependencies. We started to see issues where, for example, there was this SBT PGP plugin, and then people wanted to make use of those settings in other plugins, or Git or the SBT site plugin. And if you wanted to make use of another plugin's settings, you actually didn't know if they existed yet. You had no idea. So what auto plugins do is it allows you to create a reusable core of a build that you attach into the existing graph of build. And users can enable and disable these things explicitly. So you can actually enable and disable dependent plugins. This is actually, we wouldn't call them auto plugins if we were 1.0. We would just call them plugins because it's how the plugin API should be. As a plugin author, you can now set up a bunch of settings, say which plugins you depend on, and SBT will enforce that those plugins exist before your settings are added. So you can verify where you inject yourself in the dependency graph. These are actually really good for company-wide plugins. You want to talk about that a little bit?
Sure. So company-wide plugin is sort of the, instead of doing like a whole mono repo approach, if you have multiple repositories of the project within your company, and you want to make sort of like a homogeneous assumption of what Akka version you want to use, or like a common like standard for the coding conventions or organization names, what you could do is make an auto plugin that would automatically trigger. So the cool thing about auto plugin is you can do the opt-in or opt-out. So opt-out will be enabled by default. So without doing anything, you just include this company-wide plugin, and you can basically set the baseline settings for like you always use, like the automatic code formats or something like that.
Yeah, if you're really interested in good auto plugin usage, you should look at the what Mookie has done with the SBT native packager. It's really quite elegant. You can actually declare a project as being a Java application, and then it'll fill in the settings for Java application. And you can actually create new plugins that only apply to applications versus a Java server. So you can really customize where settings get applied and have these globally enabled plugins that attach to the correct project.
So another feature that I've been personally working on is speeding up the IV resolutions.
Well, how many people here think IV resolution is too slow? Okay. All right, we're with you.
This happens especially if you have really, really large dependency graph. I forgot to add the logo here, but this feature is actually sponsored by LinkedIn. They have this project in which they replace the homepage of the LinkedIn using Play, and in which they have like a lot of libraries, and there's this concept in which you want to separate like feature by feature by using a smaller subproject so that you can scale your organizations. But what happens then is that you have this really large graph of dependencies and 20 subprojects. So each subproject, let's say, takes 30 seconds. 30 times 20 becomes 10 minutes of you staring at SBT trying to resolve dependencies, right? So the feature that I've been working on for a while is that if you can cache the subproject, at least during the single run of update, you can consolidate all your dependencies into one place such that you can basically save a lot of time in resolving this entire massive internet of graph. Another thing we could do is basically for each direct dependencies, we can save the result of the resolution onto a machine such that you just basically replace the resolution with the reading and writing of the JSON file. So for example, when the earlier version of this came out in 13.7 M3, Ross said it used to take 260 seconds to update his whole build, and now it's like down to 25 seconds. What we recently discovered is that even that was a little slow because 97% of the information that I was saving in the JSON was actually a junk information that doesn't really require it. So this should even get even faster. And yesterday I released the 0.13.9 M1. And if you haven't tried yet, you should definitely try the cache resolution with that version if you have a large graph.
Yeah, also note to self on optimization, just because it's in the API doesn't mean you should save it. So, yes. I also want to make a note, SBT serialization is being used in this feature. SBT serialization is the 1.0 module. It is the 1.0 API, it is the 1.0 library. It's available for Scala 2.10 and 2.11 separately that you can download. We'll talk about some more modules later.
Sure. Well, yeah. A shout out to John. This is made by D6 or Eric, and also Pickling.
These are the two libraries that it uses, yeah.
It's not working.
You're locked up. Okay.
All right, good. So this is basically what has been happening in the 0.13, the previews. So towards 1.0, what we want to think about is the stability in the three different ways. So one is a conceptual stability, the binary and the binary stability, and the source stability, sort of, or the source compatibility. In terms of the concept, right? SBT is a build tool. You don't really want to relearn the entire stuff when we go into 1.0. So in terms of the Scala incremental compilers, the dependency managers, task and plugins ecosystem, and the test framework, these are the stuff that's already sort of stable. I don't think we need to really mess with that stuff. One thing we'd like to work on is replacing the text-based interactive shell that we brought into the table with a little more sophisticated SBT server and clients, and Josh will later talk more about that. And when we talk about stability, I think I've already said that plugin is like a huge asset to our ecosystem. So so SBT 0.13, for example, it was maintained, this was maybe like 3 months ago, it was 18 months. So by now it's 20 something months.
Yeah, we're hoping to push, I mean, if we can get 30, that'd be pretty awesome.
Yeah. So basically, this is maintained as long as almost like a Scala, 2.9 was maintained or 2.10 was maintained. They're basically in the order of 20 months or something like that.
Yeah. So and to clarify, we've maintained bin compat, but adding new features. Yep. This isn't just support. This is adding and providing new content, new things. So yeah.
Going into 1.0, this is one opportunity we have basically to break the binary compatibility to make sure that we can further, when the 1.0 comes out, we should be able to maintain the binary compatibility at the 1.x.y level, which is the semantic versioning. So this is what we want to do. So in order to do that, we basically have to narrow down the API exposure, because currently basically we're opening up our guts to the plugin authors. So we want to minimize that surface point a little bit so it's easier on us to maintain longer stable binary compatibility.
Yeah, one thing you might notice because of the binary compatibility, if we didn't know if a method was being used and it was an internal method, we'd leave it and provide a second method. So sometimes when you go into SBT to try to do something, you'll see 2 methods to do the same thing where 1 is deprecated, or 4 methods to do the same thing where 3 are deprecated. And that's something we definitely want to try to clean up just to keep things clean so people can access it easier. But it is important for compatibility and keeping plugins working. Like you don't want plugins to break in an ecosystem like SBT because that's the most frustrating thing ever.
So it's not that it is important, but at least for the SBT versions, the users do have the opportunity to kind of go up and down the SBT version. So we probably try to keep the compatibility of the build SBT, but this is something we may break a little bit using we may deprecate some feature or something like that, but we will try to keep the build source compatibility of the build SBT going forward as well during the SBT 1.0. But this also gives us sort of the opportunity to break the build SBT. One idea that's been floating around is, for example, deprecating the project/build Scala. So currently there is like 3 or 4 different dialects of being able to specify your build, right? There is the normal build SBT and the multi-project, and then there's the Scala one. So in order to make the cost easier for us to maintain this going forward, one idea is to get rid of the build Scala because now the multi-project build SBT is pretty powerful enough. Another idea that's been said is maybe we'll try to unify the syntax of the SBT shell and the build of the SBT syntax. So we're still following these ideas around.
Yeah, so that's if you, in the shell you would type compile, compile, and in a Scala you type compile in capital compile, and there's no reason to have that sort of mismatch.
Well, the tab completion is easier with 1, so there's still...
Yeah, there's no good reason.
Right.
Okay.
So the modularization, I think, is the way forward. I don't think we can really promise when SBT 1.0 comes out, but we can basically pull out the stable ones, like we said in the conceptually stable stuff that we can say we're not going to really mess with it. So we'll pull out the one that's cohesive, which makes it easier for us to define this is a public API and this is the internal stuff.
Yeah. So I want to just mention this is a feature-based release. This is not a time-based release. So we're not going to tell you when, we're just going to tell you what. And we're going to work until that is done, and then it's released, okay? And if you'd like to help, please help. The modularization should be a big deal in terms of getting some of these useful components out for everybody.
So these are basically the steps. So like pull it out, document it, and then clean up the historical code, and hopefully we can publish it into Maven Central. Now, we actually have I/O API that got published as the M1 a few days ago. So we can try out, and now you can just basically use SBT's I/O as a standalone library. And it's pretty useful if you're doing like a shell scripting or something like that using SBT.
Yeah, the SBT launcher is actually public. That's what gets used by SBT and Activator and CS, Conscript. So that's an API you can use if you want to launch a program directly out of Maven. It'll resolve it and launch it. Serialization is a mechanism of serializing to JSON from JSON. And those are the 3 things that we've released so far. I think this is the order we'd like to work on things next. All right, so let's talk a little bit about SBT server. Okay, there's a button. All right. Let's talk about the problem. The reason why we ended up building SBT server was we had a whole bunch of things that want to access the SBT build. How many of you guys have run IntelliJ? All right. How many of you guys run IntelliJ and the SBT terminal at the same time? How many of you guys have seen weird compilation errors? Okay, we want those to go away. We need to get rid of these. And the problem is that if two things are touching the file system and one deletes things the other one is looking at, all hell breaks loose, basically. So we need to avoid that. This was also a problem with Activator and play run. When you run play run, you're actually forking off play and it's communicating to SBT. Activator is communicating to SBT. And if you run IntelliJ, you have a third thing connecting to SBT. So it's pretty awesome. What we ended up doing was taking this simple notion of a design where a client connects to a server, and this server will communicate changes that are happening to the client, changes in state. Why do we have changes in state? Because a build is just a giant, mutable, shared state device. Okay, it's called disk. The build works with disk. You cannot get away from disk. So you have to try to hide things about disk if you want to pretend like it's not changing underneath you. Instead of doing that, we try to limit the thing which touches disk to be SBT server, communicate changes out to clients, and then we also have events streaming back, logs, that sort of thing. So the idea here is a client connects and says, here's the bits of your build I'm interested in, and change notifications come back when things change.
So this is like X window as an analogy, like you were saying?
Yeah, actually, Havoc Pennington was one of the guys who was very influential in helping us get this up and running, and he used to work on Linux and Metacity, and so this is based on X Windows. All right, so after we re-implemented, this is what our architecture kind of looks like right now. I'm just going to highlight a few things. This is what SBT is like right now. Okay, there's a command engine. The command engine takes in a command, executes it, looks to see what the next command is, executes it, looks for the next command, executes it. It's just this big churn. Where's the parallelism? If the command says to execute a task, we spin up the task engine, and then we create this parallel hierarchy of things and execute everything in parallel and then come back. Okay? But essentially we have a task engine. You can only run, or command engine. We only want to run one command at a time. A command can be something like, I want you to run these 7 tasks. Or it can be, I want you to clean. Right? If you're cleaning, you can't be running compile at the same time because you have that giant mutable state that you can't touch at the same time in damaging ways. So that's why the command engine is single-threaded, but we still get the advantage of parallelism. What we did was instead of reading the next command to run from what you type in, we changed it to read from a command queue. Okay? The command queue is just things that the client sends in. And we have a server event loop. So a client connects to the SBT server, and it might request a command to run that comes on the loop. When this thing is ready, when it's done, it will pull the next command off the queue and execute it. Okay? Simple, I guess. Except there are things that you want to do all the time in a build. You want to inspect what tasks are available. You want to see the dependencies between things and the graphs. You want to have some auto-completion. You want to check what things are running. So there's a separate event loop from this engine which has the latest state of the build in a variable, which is immutable, and we can answer requests on those live, on the fly. So there are some tasks in this which will block, and there are some which do not. And that's basically what the internal architecture is. But now we start to have problems, right? We're trying to do this distributed architecture. We have a few problems we have to solve that are kind of interesting. One is a client might not be the one to start SBT, so it's connecting to a live instance. So you need to design an API that can handle connecting to a live instance that already has state and get that state to the client. Another thing is a client may disconnect from a server and you don't know if state changes have made it to the client. So how do you react to this? What do you do to recover your state? So the design is connection is an event. Okay? You construct an SBT connector, which is basically, here's my name, here's the directory I want to connect to an SBT build, and yeah, that's the directory, and here's 2 names for you, one for logs and one for humans, okay? And then I define a connection method. This connection method is me talking to the SBT server and declaring what state I want. And it is always run on reconnect. Whenever this is called, I need to clear out whatever state I may have cached and refresh, or I can just respond to changes. Okay, so this is how you connect to SBT server. Here you can actually say, I want to handle all events with this particular callback. I want to watch a particular build value and tell me when it changes, that sort of thing. And then we say, connector, open the SBT session. Here's the method to handle connections. Here's a method to handle errors if I want a special error handling thing. This will automatically try to call your connect method until it's successfully connected. If you disconnect, it'll call it again so you can restore your state correctly. So this takes the notion of you always restore state fresh when you start. Okay? Yeah, so you want to restore your view of the build on reconnect. So that way things don't get inconsistent. The next problem we had was actually input. In SBT, you run the run task and you just type right in there. But now the thing is on a server. So how do we have the server get the input from the client? The solution is we actually create this interaction. What this is an embedded protocol. All right? So the SBT server protocol is this thing of sending events. There's an embedded protocol where anytime I request for something to run, a command, I can attach a mini server called terminal interaction. This is the thread which it will run on, where it can handle requests for, hey, I need to read a line of input from the user, or hey, tell the user this, that sort of thing. And this is where some fun things happen. But yeah, this actually works. I hooked this up to the PGP plugin for SBT server, so you can actually have it pop up a UI in something else and ask you for your password when you need it. Okay, and here's an example from the plugin standpoint. As a plugin, you're no longer running where you can just talk to system in and system out. You're running somewhere in a server. I should say you shouldn't talk to system in and system out because it's not efficient anymore. So here I grab the actual interaction context. It's a service available to an SBT build that I can pull. And from here I can call a set of higher level APIs to get input. So I'm not saying give me 5 bytes, give me 5 bits, right, over the server. That's inefficient. We want to say to the client, hey, I want to read a line of text and here's a prompt. Okay? And here's whether or not you should mask it, like this is a password or that sort of thing. So the next problem we had, right, in running SBT server is that those tasks block. When I'm running the compile task, nothing else can be running. Now what's interesting is when you run play run, okay, the play run task, it actually forks off the play server. And the play server starts up and it reconnects to SBT. And if a file changes while this server is running, it calls SBT server, says, hey, recompile, and comes back with the changes, and then the server will reload based on those changes. That's how it works. But there's a problem. If you're running the run task, you're in the play server, and it says, hey, go recompile, it's still waiting for the run task to finish. The task engine is occupied, right? So you can't do anything. You're blocked. It doesn't work. So what we added was this notion of background jobs. Okay? A task can actually spin up something that survives beyond it. For those of you familiar, there's actually a plugin which does this that forks a whole bunch of processes that I think would really benefit.
SBT Revolver?
SBT Revolver, yeah. This is targeted at those kind of plugins where you want to spin up a service and have it running during the build, and then you want to run other build tasks at the same time. So, for example, I can fork a play run application. I could also fork off the Scala REPL and have that running while my build is running. Okay? So I can actually spin up sub-processes and have them interact and not lock things. But remember that I've started them so I can kill them later. If only you could actually just kill a Java process and have that work all the time. So the next problem we had after we create background jobs is input interaction design. Okay? I want to spin off this thing like the Scala REPL, and I want to be able to type in the SBT terminal to the Scala REPL and get back its output, specifically as this client. So we have this notion that the requesting client needs to provide the means for terminal interaction with a particular guy. Logs and standard out will be sent back to all clients. This interface is not completely done yet. Right now, we can actually spin off background tasks. We can keep track of them. We can kill them. But we don't have this notion of interaction and controlling standard in and standard out that needs to occur for these things to be done correctly. All right. The next thing we had was a problem where existing plugins need to know they're running behind a server. Right? Like I said, if you are using the system in interface to pull in input from the user, that actually turns into read this byte, read this byte, read this byte, super inefficient on a server. So we want to give them an API that they can use, which we can hide behind SBT server, make it feel like you're local. So to solve this, what we did was we created something called sbtDetails. This is a plugin which you can depend on with auto plugins that will provide all of the services you need to run as a remote server process and talk to clients that connect. There's a background run service to do these background jobs that we were talking about. There's an interaction service, a way to send events, just generic events out to the UI, and serializers, which is how you register, how to serialize your test results.
The target audience for the sbtDetails?
So this is for plugin authors. For example, Play 2.4, the Play plugin actually depends on many of these. It has a background run plugin which can fork off in the background so that the whole reload thing doesn't cause compilation exceptions. It has the interaction service if it has to ask for user input, and the send event service. Play will actually notify your IDE what port it's running on in case the port was configured to be something different. So the IDE doesn't have to read that. It'll send you an event saying, hey, I started, here's where I am. So the IDE can wait until the service is started and then say, oh, here it is. That's actually in use in Activator today. That's how Activator shows the URL. So yeah, if you're a plugin provider, this is for you. This is how you write plugins.
If you're an IDE developer or Enzyme or something, this will be really useful too, right?
As an IDE developer, you would make use of the things that these send. You actually wouldn't use these directly.
But would they have to provide like a UI?
Yeah, so one of the notions behind SBT server, if I have a plugin and I have an IDE that wants to be aware of that plugin, I can actually have the plugin send an event that the IDE knows and responds to, and there doesn't have to be anything SBT in the middle. I can directly add IntelliJ integration on the plugin side and on the IDE side and be intelligent. And that's an opt-in thing. So it doesn't have to do it, but it can do it. Related to that, I just want to mention the Eclipse guys have been working on SBT server integration for a bit. They're getting very close. They're getting very close to having that out. IntelliJ, I think, actually already has it out today. I know there was an alpha that was posted that I tried out where you can actually have IntelliJ communicate with SBT server. So that's pretty exciting. Very exciting. What do we need to do next? The to-dos are basically around interaction. And this is, we want the SBT terminal client that you use to connect to the server. To prevent this disk corruption, we basically need everything that uses SBT to communicate to server so the server can own the state and so that none of this corruption happens. We exposed enough of SBT server so IDEs, Activator, Play can make use of it, but this is now the more fun part, which is ANSI terminals. The other thing we want to do is actually have the meta project be a first-class citizen in SBT server. Right now, if you want to type reload plugins and start investigating plugins, it gets a little bit wonky because suddenly everyone gets notified the build has changed. So that's actually currently disabled. And then we want the tilde, so recompile and change, to actually be first class. We want that to use file notification watches. We want those events sent to everybody. We want you to be able to say, hey, rerun this on file change, just as a first-class citizen in server, but not the current blocking mechanism. We want it to actually use the file watcher APIs. We also, one of the common complaints about having a build tool that's a server is actually around JVM memory usage. When you allow plugins and unknown code to run in a server, just FYI, if you allow plugins, it is guaranteed that someone will have a memory leak at some point. It is also guaranteed that this memory leak will cause you to be completely unresponsive due to a giant GC happening at some point in time. So if you can detect this thing and kill yourself before it happens, then what the user experiences is why is my server restarting, but at least it still works. as opposed to this is completely unresponsive, right? So that's the goal, is to try to find, detect memory loops, and prevent them from happening. And then fixing the SBT terminal client. I wanted to actually demo to you guys today, but I didn't finish it. We actually have this nice reactive terminal where with SBT server, we can actually have command line input in like one widget and log output in another widget. It's like in a prototype experiment we're doing. Just if you're interested, let me know. It's in my streamers library, but it's a cool idea. With SBT server, we can actually do a lot more for advanced terminals, and we can have a nice simple one for general usage. So lots of cool stuff coming.
So I think I earlier mentioned that we're trying to get more help from the community. So this is a list of things you can go to from the scalasbt.org. There's this page called Getting Involved, and follow along our Twitter, Scala_SBT. And there's a lot of ideas you can bring in on we're typically hanging out in the Gitter. So just check out these things.
Get it done. Thanks, guys. I think we don't actually have time for questions because we went over. So if you're interested in asking questions, we will be outside the room. You can ask questions. Thank you, guys.
Thank you.